Viola actually came to our first ever AWS AI UG, and she called me afterwards and said, can I do a talk? So, over to yourself. Thank you.
Thank you very much for having me today. Yeah, my name is Viola. I'm a software engineer. Currently I work at a fintech called Invest and Fund. I am responsible for owning the front ends and the infrastructure in 3 core applications, one of them being the internal, the other 2 being external that are facing our developers and lenders, developers being the people who develop the residential properties around the UK, not the actual software engineers. And I also do, I created and I maintain my 5-a-day app, which is an application that tracks your 5-a-day intake. Let me see if I can switch the slide. That's the website for it. You can check it out. It's always a work in progress. I'm currently migrating it from one container to another, so it might be flaky. It might do something, but the authentication should be working, although some assets might not. So yes, that's about me. Generally, I do work with AWS primarily. So even though I prefer IAC, like infrastructure as code, using Terraform and being cloud agnostic, I still believe that AWS provides us with a framework of really nice tools that have been there for more than decades, and that sort of experience that they're bringing us with, introducing us to us, I think that sort of helps. Because they have an extensive documentation. That's why I'm staying with AWS and not switching to anything else, even though we have some services on Azure. AWS is our backbone for everything. Yep. So without further ado, I'll jump into my topic. So today's topic is AI-ready front-ends. I know AI has been already in the picture, in the grid for quite some while, since we've seen the first release of ChatGPT 2022. Obviously that was not the first model, but the actually meaningful model. People have started to integrate those AIs into their applications, and I'm seeing that there's been an increasing number of incidents these days because of the security vulnerabilities in the applications when people are integrating AI and the front end is not really ready for this AI to be really integrated in that application. There's been many factors to this. I've separated out 3 main factors, which are they are listed here, but I'm gonna talk through. So the first being is AI is not a feature anymore. It's more than a feature. It's basically a part of your system right now, and it's gonna be touching some really sensitive information that is interacting with your application from the backend. So you are going to be passing personal identifiable information. You're going to be passing details that are connected to payment info, potentially really sensitive data. So be it a chat that you have like an agent that is helpful to your users, to your customers, to people who just visit your website, or is it maybe like some helper agent to integrate within your application like HubSpot does, and that has proven to be very successful. Unfortunately, not all of those measures to secure the data on the backend has been taken, and AI integrations have been kind of built on top of what the system is already is in production. So secondly, we have the important part that authentication and the authorization and the role-based access, RBAC, is very important in this scenario, because what authentication is essentially is your guard against all of the people who want to access resources, and roles are important in this type of thing. Therefore, whenever you start integrating AI into your application, I think the first thing you really should think about is the authentication and the roles that you assign to people, and if it's really clear, if it's really working as it's supposed to do, or is it just authenticating and just issuing you tokens to authorize some people on the platform, and really just let them into the application in a really funny, toying way. That is very important to understand. I've seen that especially startups where there is a prototype, it has been a problem that people don't really care about authentication as they should be. And there is 2 core standards. I currently go by the OAuth 2.0. Everyone knows that. That's something that I'm going to talk further about, but it's the core concept, on top of which right now there is a draft of 2.1, which removes some of the security vulnerabilities because we are moving towards the era of mostly SPA, single page applications, apps that handle data state management, and we have completely different to what we used to have applications right now on the front end, rather than simply serving static assets, and that's why we should adapt. And then finally, the third one is about safeguarding and placing guardrails on your backend, because front end is basically just an intent. We don't want to make front end validate anything because this is not secure. What we want to do is have backend to filter all of the things that come from front end. All of the intents should be validated and checked against the rule sets that we have. And then when the backend decides that it's safe to proceed, that's when we can access and interact with the AI model, and then also have guardrails against attacks like prompt injections and similar, so that people don't really exploit your model as they might want to do, given its free tokens. So what can AI feature do to your system? Many things. I've again just separated 3. It can see your users' data in a way that, for example, if I'm a user, a customer of a platform, and it has a table. So imagine your backend has tables for storing very important information. And imagine that there's just one table that if I ask the AI to show me, it will bring me the whole entire table with all the users' information. Now, working in a fintech, I know that this is a pain. You gotta separate concerns, you gotta have different tables, you gotta have permissions, and you should not allow anyone to see that user's data, especially the PII, the personally identifiable data that can be linked to people and used against them or for whatever reason in real life. Therefore, that is one of the top vulnerabilities I think I would say that there is to integrate your AI into the existing application that you've built maybe in 2010, maybe in 2015. And maybe even yesterday generated using prompt, and that application is not secure because there is no engineer to safeguard against things like that. So then secondly, it spends your money on things like tokens, GPU usage, API calls, and that is one of the problems that I've seen and could be more visualized, but I think everyone has heard already that so many secret leakages have been discovered ever since AI has launched. Their APIs, AI models like ChatGPT models, Copilot. Copilot is using ChatGPT these days. There's Claude, and those models we can use just by having one single token, and that token sometimes get leaked online and you can use it so many times, and you're not going to be paying the bill, which is great for those who use, but not for those who pay, because overnight you can generate so many tokens that they're just going to be flying over the wall, cost you in like thousands of pounds of bills. And then third one is, I know that so many people, instead of creating their own LLM, like having a llama running locally or on your server somewhere in a container, they would go and resort to using third-party models. Obviously not talking about the privacy here and not talking about specific third-party models, but I would suggest that there is some kind of backend in the middle between your application so that users are interacting directly through your backend and interacting then to the third-party models, because you cannot trust a generalized model. You need to train it specifically case by case. So there's 2 mental models I like to think about when I see the applications being used with AI, especially with the front end is not really adapted. So there is a case where people integrate AI API as a backend, and they use it clearly with the rest of the infrastructure of the application, which basically lets browser to talk to your application with no guardrails in between. There is nothing that would say, oh yeah, wait, let me check that script, let me check who is asking, let me check what is the role. There is nothing, so they would be just directly talking to the AI API. And if I wanted to, I would open a console network tab, get the application, actually get the local storage opened, and get the token, and literally authenticate myself on the server and hack into it, which is pretty simple to do. So yes, the front end will hold the access tokens and will send the HTTP request straight to the AI provider. As I said, that is something that I've seen happening with many applications these days, especially those generated and not really being audited by human engineers. However, I think that the second model basically represents your ideal use case. Obviously, this is really generalized, and we can go into diagrams, we can discuss what steps you should undertake to really do this. But generally speaking, browser talks to your backend, and the backend decides where to send the request and if we should even proceed with that request. So AI model shouldn't be the one who decides. Your application should be quite straightforward, and we should be, as architects, deciding where to route those requests in our application. So I've also mentioned actually the backend for frontend here. So with the frameworks I work with, like Next.js, they are a full stack runtime environment for applications. So you don't even have to have a full-fledged backend somewhere on your ECS or whatever you're hosting it. You might just want to have like an EC2 instance where you manage it all yourself with your database sitting on a separate instance. That's great. But backend for frontends, which is BFF, is something that Next.js allows you to do. Just literally do requests from your frontend, whatever the frontend needs from the backend. The backend is just sitting there and serving whatever you want straight from your frontend. So yeah, I've outlined there. We can call API gateway, which will gate then our request to trigger a Lambda function, and then call that API AI API provider. And then we would also check before we even call that AI provider for the particular role, and if there's anything that we should be cautious about that prompt that we are sending. So yeah. There is Auth Foundation I wanted to talk about before we even dive into the series diagrams. I specifically use Cognito with Cognito 4. It has the OpenID Connect plus PKCE. So these are the things I would say, the main things that you should be looking in the IDP and the identity provider when you are integrating any authentication, be it a Keycloak or Cognito. There's many providers that you can use and choose from, but specific case, AWS, we're using Cognito, and no custom authentication in this case, which you can absolutely do with your Lambdas and API gateway. So yes, fix your authentication before you even start thinking about the AI in your application, because implicit flow has proven to be very vulnerable, especially because we are setting basically the token that gives us authorization to use the whole entire application in our local storage. So anyone who wants to do a little tiny nice XSS attack cross-scripting, they can pick this up and then use and authorize as if they're you, but it's not going to be you, but they can be using your resources. And if you're paying for that application, they can, I don't know, use the whole tier that you are paying for. Great, they've just used your subscription, and you're not the one doing that. Then we have OpenID Connect plus authorization code plus PKCE. So if you're interested in learning more about OpenID Connect authorization code, how it works, and on what framework it sits, I have recently delivered a webinar that talked about this really thoroughly. So that is something you can see on my LinkedIn page, but I'm just going to quickly cover this. So OpenID Connect is a framework sitting on top of the Auth 2 protocol where this is for authentication. There is RFC standards that you can read, which is really interesting but very boring. And you can literally see how OIDC is basically sitting on top of Auth 2. It cannot be used without it. And authorization code is something that we should be getting instead of setting our token in local storage. And PKCE is just proof of code exchange, which serves just purely to instead of getting your token and literally bringing that token all the way through the journey of the authentication, it will create a hash, basically a hash. It's not a hash. It's another token that will just say, yes, we have that token there. That token will be on the server, but the token from PKCE is just going to be traveling through your application, and eventually, if the role is correct and it matches out, then you will be allowed into your application. And finally, the tokens on the server browser gets a session code. Yes, so your tokens, they should not go to local storage. They should stay on the server. I have a really nice diagram afterwards that shows really nicely how you should really just gist out the token to sit on a separate branch rather than sitting in your local storage. And I know it's really tempting to do an easy flow, and it's proven to be really easy to set up. Really takes you, as a developer, would take me like 20 minutes to set up an authentication flow with implicit, because you don't really do anything because you just set it in local storage as a key, and you just use that for everything. The worst thing that can happen is, well, there's many things that can happen and go wrong, but the worst thing that can happen is literally you're not expiring it, so it's just sitting there until you really clear your browser, which is, you might not even do it anywhere soon. So yeah, you should really get an HTTP secure same-site cookie to authorize you throughout the application and throughout the assets. So yes, I've compared out the implicit flow and authorization code PKCE in a single page application. So on the left is the way you should not be doing this. Implicit flow is bad for our applications in 2025, coming to 2026 and forward. So you should really not use the response type token. You should not set your token into URL fragment. If you see a URL with literally the JWT token, which is your access token for your application in the URL, you shouldn't use that service because it doesn't care about your it doesn't care about your data. It doesn't care not about your data, but for everyone else who's using that application. So that is something to think about it. And you can literally recognize it by having a bunch of gibberish inside the URL, because the URL is going to be, instead of a domain name, it's going to be like really long, and you'll be like, oh, what is that? That is your key to the kingdom, basically. So authorization code and PKCE allows us to avoid those types of scenarios, and tokens will be returned only from the endpoint that you go to. So the backend endpoint that you say, this is my auth endpoint, and you're going to be returning all of the information from there from now on regarding the authentication of all of your users. And then based on the returned results, you'll handle the cases. So yes, URL will contain only the code. So you can see the question mark code equals, that's just going to contain the short-lived code. It's not going to be accessed, cannot be accessed forever, because that code is just going to expire. And that's one good thing about Cognito, because Cognito handles for you that whole journey. All you have to do is follow really clear instructions with Cognito if you don't want to go deep into the authentication. But the good news is Cognito is literally using the OAuth 2.0 standard. And when you go to set up your sessions, when you go to set up Cognito to integrate it with your application, you basically, you see that all of the things that they write out, and even in the order, if you go to the RFC standards, it's exactly the same. So they're going by the book, and that really just makes me feel really good about this, because I can trust this service provider, and that's why I'm not going to use anything else at this point, because Cognito is doing things for me that I don't have to spend days and weeks delivering those features. So I have a nice diagram here, which is, well, it's it maybe looks ambiguous at some point, but so this is just showing you how Cognito can authorize your users in your application. So this is where we start. That's the browser, right? So we come to the application. We use Amazon Cognito hosted UI, which is one of the options you can use. You then go to browser. And that's not you going to the browser. That's Cognito doing this for you. So Cognito goes to the browser, redirect URL. It gets your code. It then sends your code to the backend, or backend for frontend. You've got Next.js API route, whatever you have. Then it sends that code plus code verify to the Cognito token endpoint, which is the point that Cognito will set up for you, so you don't have to care about. So then it will return the ID token, the access tokens, refresh tokens, anything that you have for your applications. I mean, there is different cases for different applications. Some applications don't have secret, client secret, because they're SPAs. Others do have it because they're mobile applications. No, they're older versions of applications. So this is just based on the cases. And then your backend, what it does is it stores tokens in some session, and that session is there on the server. It doesn't get to the browser. So that your backend only returns the HTTP-only secure same-site session cookie that sets in the browser. And you can also see that in the application tab. It's similarly like the local storage, but it sits in a secure HTTP-only storage. So it's a session cookie, which is very secure, and that makes sense to use. So now we are going to the next part of the talk, which is the boundary, where we will talk about the browser versus backend and AWS, how we can integrate. So one of the patterns I like to talk about is the tokens that live on the server, and the browser gets a session. So I've just covered that bit where our backend just takes the token from where we've already passed it through the tunnel that verified your role, and it brings you back to the browser. And the browser only knows that that session cookie, it expires, it's got max life, or you don't set it, but the best practice is to do, and it will expire at some point. So that's what makes it secure. So the browser will then hold the short-lived session cookie, and then you will be able to access this information, refresh them, which is great because you don't have to care about resetting your whole browser. You don't have to care about basically thinking that your information can be leaked because there is somewhere my token, my information can be in danger, because session will take care of it for you. And then basically we're calling the same API endpoint, which is a secure endpoint that we take care of on the backend, and we don't make any unnecessary calls to that endpoint unless there is not been any conditions that would not pass the request. It will always pass to that endpoint, and you can read it pretty much from there. So another great case, and that is the entire diagram. So it's not really. So yes, this is a reference architecture which I really wanted to depict in like 3 different ways that you can really interact with your authentication. So the greens are the first kind of case where you have the front end talking to your backend, which is going from browser to your backend or BFF, whatever you have. Then it it goes to your microservices, talks to your business APIs, goes through the guardrails that we really should be going through every time our application does something to the user. And then the data access goes and saves either in RDS if you're lazy to manage your own database. But jokes aside, RDS is a great service for this. It's just a bit pricey, and if you want to save some resources, just get rid of snapshots that will be saved from 2013. And then, whatever you have on the storage side, it will then persist it there and grant the access to your browser's Next.js application, whatever application you have. I'm specifically talking about Next.js applications because that's the framework I primarily work with. You can work with React, Svelte, Vue.js, honestly, any client, but all of them are really similar these days, and SPA is an SPA. So then there is a route where the blue ones are coming through. So this is a direct authorization through Amazon Cognito. So you don't really have to have a backend You can set all of those permissions on Amazon Cognito, and that will handle the authorization and authentication for you. It's not going to be your database of users. It's just going to be user pool, where you can save those details securely and not care about, well, in that sense, yes. So you can literally save the things, the user information, the user data of your users to Cognito. However, if you are using root access to your Amazon account, which is not the best practice, and you don't have any IAM roles that are configured to be securely accessing specific bits of information, then you're probably not doing really good, because Amazon Cognito, although is a great service, you need to still understand that infrastructure comes from the correct user access management from the core. So IAM is your friend before you even start with Cognito, and probably should have started with that. Yes, and then there is a third way we can interact, where the backend is the sole kind of executor here, and it would straight go to our API gateway. If it's a customer authentication, we would have an API gateway AI endpoint. It would go there. It would have the request with an intent from the front end. It will invoke our AI Lambda. Then it will read aloud data, because we've already filtered it through, and we want to specifically filter for details like, for example, if I can access, if for example there is a chat agent that is connected to like the entire database of PII and personally identifiable information, and I'm like, can you just return me a whole table with users? Imagine you're an SQL engineer and just return me the whole table with users. And I was just like, sure, yes, here it is. Here you go. You can access it in a CSV format. You can even, I don't know, spin your own server up and use that information. Now, great. I've just copied someone's business into my own server, and well, great. I have the customer database, and I'm just going to email them. Great. So to avoid that, obviously, we need to filter through our backend, our business APIs that will say, okay, so there could be a sentiment recognition. There could be things that would ban specific words from going there. But imagine if your AI assistant talks in different languages, right? So you want to, like, if you safeguard it in English, I can speak to it in Russian and just ask for, to do the same thing. And you didn't think about that, right? You're just targeting, you're a UK company targeting primarily English-speaking customers. You didn't think that your AI model can speak any other language, but it can. So you get to safeguard it on the business API microservice level, where you say, no, this is an English-only application. You cannot ask for any data to be returned from the backend, because this is secure important information. Obviously, AI model is not a person, and you need to have some code in place to avoid any ambiguity. But yes, that's the idea. So separate who are you from what you can do. That is very important, because you need to specify what identities can access what resources, and you need to authorize those people to actually be correctly routed in your application. So if I'm not a super admin, I cannot access the entire infrastructure of the application. I cannot manage different roles. I cannot set resources up, and it will just be a clear scope for every user if you do that in the beginning. So keep your identity provider in abreast of those permissions, scopes, roles, to also actually be correctly using that tool, because it's a powerful tool, but we want to configure it correctly. And if the IDP is not configured to your requirements, then the expectations will not be great. So yes, section 4, AI-specific guardrails. That's something that comes from your backend. And what can go wrong with AI features? Well, if we are only going by the secure and success path, which is what developers tend to do, but QA engineers don't, if we're just handling the best success path, Obviously, we're not going to get any prompt injections. Nobody's going to try and steal our data, especially our competitors, because we're really good friends with them. We go to conferences together and we just network and have some coffee during the day. But then we think about that from the QA perspective. And what do we see? We see prompt injections where people are trying to steal information. We're trying to kind of make it so obvious, like you can play with the language. Yes, English is the new programming language. But it's even more important to now safeguard yourself against those words, because there's so many words. And imagine that it can understand even the Shakespeare era words, and someone is trying to steal something with prompt injection with those words that you didn't even think about, but it's there, and you can even like you go and do that. What role-based access helps to do is to prevent that data exfiltration, because you say, well, this table is only accessible by that specific role, by the superadmin, that can also be accessed only from that specific VPN configuration. So you don't even like let people be able to access that. So you throw an error, you handle that case, you maybe say, oh, I didn't quite understand you, and you show that there is, other ways to ask your questions. Maybe you're just suggesting even the question. That is good. So there is tricks there is ways to trick your model. So you should always be aware of that. And frontend is just a layer that shows the intent to the backend, and it's up to the backend to then convert that into something, and then talk to the AI model. Whenever I talk about authorization, authentication, I also like to think about it as a when you go to a nightclub, you have a bouncer in the doors, and you cannot be passed by that bouncer unless you actually present your ID. Maybe there is people who look older, but to me, I always get that problem. So that's how I kind of related to this. And you always present your ID. So that's the similar way you should be doing with your application. And never avoid those configurations, because Cognito actually provides you with those tricks to set up the correct role access, and that helps avoid those prompt injections, incorrect data misusages, and stuff like that. So cost explosion. Cost explosion happens when we are hammering our endpoints and we don't have any rate limiting. We just don't care about that. But when we just launched our application, happily announced that on LinkedIn, and then people start to check this out. We see an open GitHub repo with your keys on it. We can use those, or we can just simply go to your application, and because, well, we've already seen that the keys are there in GitHub, what makes me think that the application is secure enough to actually have rate limiting and secure policies in place? So we just go to that application and request the entire data. We can even use it for our own needs, because the model may be really well configured. People are paying a lot of money to really kind of supply the best models. We have like ChatGPT 5.1, or we have any other assistant that can be interacted with. You can have a pro subscription, but that's going to cost you a lot of money if you don't configure the correct guardrails against that. So, and oversharing. So front ends, they are stupid. We should understand that. And front end will only try to do something that the user wants it to do, unless there is something that validates against it, against the attacks, against maybe things that we don't really want our front end to see or do. All it will do will be your messenger to the backend. So we do not need to have any raw data interacting with the front end. Similarly, as we don't want it to interact with our AI API, where our agent is running on the server, so that we avoid any leakage of the data. And again, that all just goes back to the authorization and authentication. I have another great diagram here, which is where front end is actually is sending the intent, and then the backend builds the prompt and returns all the way back. So you can start from the browser, from left to right. I always do my diagrams in the same way. So read it from left to right as a sentence. So you have your browser UI, where user types show me the tenant's loan history. Great. it goes the intents to the backend. The backend checks the authentication and the role. It will make sure that this person has the actual rights to ask that question. Similarly, how people are when they travel, they go through the security port control. That's what we're doing here. So we decide, our backend decides what data that user based on that role can see. And then we assemble a safe prompt that we can pass then to our data sources. The data sources will be getting the fetched allowed data from our backend, which has already filtered it. And then we will see in the data sources what can be viewed by that user. And we'll return that safe subset of data to the backend. Our backend then goes and prompts with the redacted data the AI provider or model that can be Bedrock, OpenAI, internal model, anything. You can spin your own llama on your own server, and that's going to be your AI agent. And that will return back to the backend the model response, whatever AI generated the answer to the response that you've initially queried, and that will then answer to the user. So that takes a couple of seconds, but the leakages that can happen if we don't have the two layers in between, the AI gateway and data sources, they can be really harsh, and the reality is going to be really hard when you see a bill for $50,000 on your AWS for just using the model, and it wasn't even you using it. So you control the spend and you control the abuse at the backend. React doesn't care about that. React, as a framework for frontend, it doesn't really care about that. All it cares about is the actual rendering of the data, showing you that this is how we display. This is our nice front end, our facing of the product, which is great. But it's not going to care about all of your data. Like, it's just going to be, yeah, sure, have at it. It's just going to be really great, but the backend is the one who's supposed to be a serious layer sitting on the back, on your servers. Nobody sees that, but it will never expose any details. It will enforce per user roles. It will enforce the quotas, the rate limiting that you have, and there is great services on AWS they can use to enforce the rate limiting, the different scenarios that can be used as attacks. So you can always start a guardrail, have a guardrail in between in place, so that your backend is microservicing and it's all separated out. So that one thing fails, you don't really care about anything else that it will fail or it won't work. You can even do that with a monolith, but it's just going to be less flexible. Microservices is what I would say is the best, I think, even for smaller applications that would still have some traffic, about 20,000 users minimum. I would still go for microservices because microservices adapt to yourself. And if you want to integrate things like AI tools that will be used in your application, I would go strongly with microservices because that allows you to be flexible and not change the entire infrastructure because of one small thing, unless you have issues with authentication. That's the first thing you should really think about it when you are developing an AI model for your application. So, and then, yes, always track your token usage. I have alerts for all my applications in anywhere I create a front end and anywhere I'm using the AI agents and even just normal user requests. So similarly to how you would alert yourself about incidents, about something gets failed, CNAME fails or whatever fails, I really like the DevOps side of the application. So I tend to talk about how something gets unavailable and you get an alert immediately and you fix it in 5 minutes because you know exactly where to look at. Hopefully you've got documentation on your projects, but even if not, then you can always ask AI models to help you out. So yes, that is very important to track your spent usage and put your basically what's the maximum that you can hit in a particular period of time. So in a month, for example, don't use more than 20 grand on AI for our users. So yes, least privilege I am. As I mentioned somewhere before, always attend to your IAMs. You have to set up the rules from the very beginning. So similarly to authentication for your users, you got to set up your application usage in a correct way as well. So obviously Lambda is not going to be controlling any of it. Your IAM is going to be doing that. So only use specific endpoints to access specific APIs, and there is not supposed to be any wildcards in your applications unless it's a safe Docker environment locally that you're testing out primarily. But again, that's just for the testing and not for production. For production, you should always use the rules, the course policies. You should always use the actual well-defined policies and security groups in AWS that will help you guard against that. So yes, and then testing it. So testing is the thing that I really like to attend to as well. So end-to-end testing is what I do with Cypress Cloud, another tool that is really great, and I'm also Cypress ambassador. But I really like to test these scenarios where we involve some payment data, where we involve something really sensitive, because end-to-end tests can actually help you spot any inconsistencies with your application. For example, if you can access something with one row that you're not supposed to be accessing. So maybe you're not supposed to access a particular page being non-authenticated, but you can do that. Maybe one person can share a role with another person, which is not supposed to happen. So that kind of thing I would always test for, and to clearly define the requirements and expected result and actual result, you should really go and document like what your ideal journey is going to be. So from a developer's point of view, I would always go and write a sentence in English and then try to translate it in the code, have some pseudocode out, and then create the actual piece that will then authenticate and authorize my users. And then obviously work with infrastructure. AWS has nice tools to do that. And I'm going to be, I think I've already said that many times, but it has really nice tools to set up the infrastructure for success rather than for failure, because even though it's complicated, then use tools like Terraform to help you with that. That can help you set up the rules, and it's not going to make you do that. That's going to do it for you. So, and guardrails for the backend, as I said. Everything has to go through the backend. Unfortunately, you can't just generate an application and expect it to be secure because AI told you so. So we've got the front-end talks to AI, backend brokers AI safely. That is one thing I actually think that's kind of summarizing the entire talk. And basically, it allows you to filter what the front end sends to the AI model, to the backend, and then backend will broker it safely. Same thing as the border control does. Same thing as we would go and check bit by bit all the packages. That is something that's very important to set up for success. The application that you're developing and integrating with AI models. And then obviously network tab is your guy where you want to see what we're calling. That's something that's useful for developers, but still if you go and inspect your browser and you can just see in your network tab what your application is calling, what packets are getting sent. You actually can see what, the kind of infrastructure that the application you're using is using, and make your decision based on whether you should be using that or not. And backend logs are very important. The same way as I said, we are setting the cap and alerting to our Slack, to our Teams, anywhere. Backend logs are very important to understand what the users are doing and what roles are being accessed. So yeah, that is very important. I have a checklist I will be publishing after this talk to my website, and I'm going to update that on LinkedIn. But so there is 3 rules I would particularly specifically derive from this talk. Never let the browser talk directly to your AI providers, as I said, and been saying all the way. You should never allow your front end to talk to the AI provider without any backend in place, or at least any rules in place that will safeguard that. Keep tokens on the server. As the diagram showed you, it should be a separate branch. It shouldn't be anywhere in the browser. It shouldn't be near the browser. The browser never knows about your tokens, and keep it that way. Browser is your partner, but it can be your enemy as well in that sense. And treat AI endpoints as high risk. It's always a high risk when we work with money. In a fintech, we have a lot of transactions happening every day. We handle millions of pounds for people in the UK, and that is a risk that we would probably say is the highest risk that can happen, because we can literally spend our entire lender's money on AI endpoints, and that's just going to be the reality, and get into debt, which is bad. And that's why we take all the steps all the way from the beginning to set up the architecture to be actually secure and rate limited, and have some places where people, will have some filters on top of it, so that people can't just prompt you your model and get anything out of it. So yeah, that is the entire talk. I hope it wasn't too technical and it was interesting. So ask me any questions about that. And again, AI should be guardrailed if you're using it with front ends. So you never should really go and have a front end with AI straightly integrated. Just use a backend as a layer to actually set the policies up for your application. Yeah.